So now we will hear a presentation of a submission from Karol Gugala from Ant Micro and Matt Cockrell, Google. So the title of the presentation is Enabling Collaborative Chip Design in the RISC-V core and the Caliptra RoT project with Chips Alliance tools. So, Karol, please.
Thank you. Thank you. We made this presentation with Matt. Unfortunately, Matt couldn't make it here, so it's going to be only me presenting that. Sorry for that. I hope I'll manage to replace Matt here. Okay, so today I'm going to talk a few words about enabling collaborative chip design in open source with RISC-V VeeR core, within Caliptra project, within Chips Alliance organization. So Chips Alliance is an organization focusing on enabling open source development of chips. Basically we focus on enabling anything that is required. So building blocks like CPUs, like I/O IPs, like interconnects, like machine learning accelerators, all the stuff that you need there, but also tools, tools for designing, for verification, for simulation, and to maintain the workflow of the whole development workflow. We are governed by the Linux Foundation, so we follow the standards like globally approved by many organizations, including RISC-V. From legal perspective, all the code that we have, like most of the code that we have, is licensed under Apache 2.0 license or Open Web Foundation license. There is some exceptions, but they are also licensed on permissive licenses, but not Apache. So the goal here is to share resources and participate together in building like the common part of reusable code for every single partner that is there. So one of the projects that I'm going to talk about, one of the Chips Alliance projects that I'm going to talk about is VeeR project. VeeR is not a single project, it's actually a family of 32-bit RISC-V CPUs, open source RISC-V CPUs. Currently we have 3 flavors of those. So there is EL2, a very small, tiny processor focusing on low power and being usage in small microcontrollers. There is high performance core EH1 and its follow-up dual-threaded EH2. So all variants of those are implemented in System Verilog, and RTL is ASIC proven, so we can freely take it, integrate with your bigger system, and use it. Caliptra is an open source root of trust block. Basically, it aims to be a block that you can take and integrate with your biggest system, and without bigger effort. So it should be easy to just grab it, integrate with a bigger system, and use it there. It has 2 flavors. It can control like your bigger system, so basically it starts, validates the whole software, and runs your bigger system, or your bigger system can start by itself and just use Caliptra for validating the software and maintaining the security on your chip. This is collaboration between, it started as a collaboration between Google, NVIDIA, Microsoft, and AMD. And the main development is done under Chips Alliance, basically in GitHub repositories within Chips Alliance organization. However, the project originally started and the specification still lives there. It's an open compute project. So if you want to read the spec and see what's there, you have to go to Open Compute project. Caliptra uses VeeR core that I mentioned before internally, and it also reuses a bunch of OpenTitan peripherals. We heard about OpenTitan project earlier today in one of the keynotes. Those are good quality cores. Caliptra reuses them. It doesn't reinvent the wheel. So our role, Ant Micro role within the project, is actually working on lowering the barrier and enabling multi-user, multi-developer collaboration on that kind of projects, on open source silicon projects. We also took maintenance over VeeR core's family, so we tend to improve that. But the main goal here is to extend the ecosystem with tools allowing like seamless integration, allowing seamless joining to the project and collaborating with the current developers. So for that, we need, first of all, tools for working with the code to maintain the code quality through the whole process. Then system level testing and integration testing to be sure that it still works. And of course, since that's a public project, that's an open source project, we need public CIs so anyone can actually see if their contribution work, if they don't break, anything, and so on. Yeah. So when it comes to tooling, like development tooling, we heavily depend on Variable. Variable is a project originally developed by Google, then open source and donated to Chips Alliance. It's not a single tool, it's rather a suite of system Verilog tools that provide various functionalities like linting, formatting, indexing, and language server. And when it comes to linting and formatting, that's of course pretty important to ensure that developers follow the standards, follow the linting rules, that they implement the code as the whole community agreed on, or steering community agreed on, and the formatting is consistent through the whole space. So of course, we can enable things like running make format and just trust people to run it, but it won't happen. People are people. Sometimes it's the middle of the night, you're finishing something before the deadline, and you forget to format the code. So we had to introduce something that will automatically check if every single contribution follows the standard. And since we are working on GitHub, there was obvious choice to use GitHub CIs called GitHub Actions. And to lower the barrier of integrating those linting and formatting tools, we created something called action that you can use in your repository. It's super easy. You just include that in your CI specification, and it will grab the tools, run it through the code that you pointed to, like, for example, every single system Verilog file within your project. And the typical use case is run it on every single pull request. So the plugins will basically comment on pull request pointing out the problems. Like here you can see the example of linter saying like, here you left white spaces. Here the block statement must have a label, yeah, and things like that, because we force those rules there. Linter is a little bit nicer. Not only will it point you the problem, but it will also suggest how to fix it, and you can apply this fix by just a single click. So it's a bit nicer from like a human perspective. But that happens in CI. That happens when you commit the code. To enable to like make it easier for people to work with the code, we created a system Verilog language server, also a part of Variable. So if you are working with system Verilog, I highly encourage you to use that. That's super useful tool. Basically, it does whatever language servers do. So it provides you the functionality of auto-completion, of like jumping to definitions, finding references in the code, and so on and so on. So all those cool features that you know from like C++, Rust, Python, programming languages, you can have them in system Verilog. It's super easy to use. We have documentation saying how to integrate that with your editor of choice. If there is nothing about your editor, please file an issue or even open a pull request with information how to add it. We also have something like auto expansion. This is somehow similar to Emacs Verilog mode. So basically, if you write a Verilog code, that's one of the examples. Often you have to write the same information twice, like in module declaration and then below saying what is wire, what is what, and what's not. So this one will allow you to just write it below and then use auto expansion to just fill up the module definition. And if it happens to be that Visual Studio Code is your editor of choice, it's even easier to use Variable language server. We have a Visual Studio Code plugin. You can just install it from a marketplace and it will work. Currently we support Linux and Windows. For Linux we have static binaries, so it should work on most of the distributions that are there. We don't yet support macOS. However, if you happen to want to be If you happen to be a user of macOS and you want to use it there, any help with adding that will be appreciated. So with all the tools for development in place, we can focus on testing whatever code was actually done and contributed. And since we took over the maintenance of VeeR, we started with extending VeeR infrastructure with some tests. And public release of VeeR back in the days didn't really include like the very detailed test suite that was available for the original authors, but they didn't contribute that, they didn't include that in open source release. There was only like a high-level, system-level tests. So within the project, it was actually pretty important to extend that. So we started adding those tests, like smaller testing various pieces of the system. So it's already there. It's integrated with public CI. Not every single part is right now tested, but we have a coverage report so we can see what's missing, and we're still working on getting that fully tested. And of course, testing at the core itself is not the whole. Something bad happened. It's not what we want. I mean, like we want to have like tested to test everything. And since we use VeeR in Caliptra, Caliptra has like a number of tests. The whole test suite, very, very good test suite that covers a bunch of functionalities there. And however, those tests are actually implemented with UVM, and there is no open source tool that can handle UVM simulations, so we couldn't really integrate that with public CI. But for the time being, we can use tools like CocoDB or PyUVM to handle those tests. But there are also more complex frameworks like RISC-V, allowing you to run simulation verification against RISC-V specification and check if your core is actually compliant with that. So this is also a project done by Google and donated later to Chips Alliance. We integrated this with VeeR. I maybe will not go into very very detailed story what happened there, but if you're interested, we can talk afterwards. But right now, RISC-V is a part of public testing, public CI testing VeeR course, so we can always check if it's compliant and if your addition doesn't break anything. During this work of like testing the core itself, we find it very useful to use like a standard software development tools, software testing debug tools to actually be able to check if the core works correctly. And within Caliptra, there is a JTAG interface that actually allows you to connect to the core and run some debug routines on it. So we use that. We added on top of that some like a glue code allowing connecting from OpenOCD and GDB through that to a core under simulation. We wrote some like some scripts for testing and of course use that for development. And then we thought, okay, that's a cool feature. Let's contribute it back to the repository, include it in test suite. And during this process, of course, some comments appear like, let's add this test, let's add this test case, and so on. Actually, we found an issue there that we cannot really access peripherals from debug interface, which was good that we figured out that then, because it was fixed, covered with tests, and right now it is there, and we can rely on that. And we can run those tests in public CI. But it's not always that easy to run tests like verification of ASICs, of like bigger RTO projects in public CIs. Since we are working on GitHub, the obvious choice was like, let's use GitHub CI. And GitHub offers some runners, some computers that you can use to run your tests. However, those computers are not really powerful, and sometimes the verification flows require a lot of computing resources, a lot of memories, and can be long. Also, as I mentioned before, not always you can use open source tooling only. Sometimes you have to fall back to proprietary, and proprietary tools require licenses and so on. It's not that easy to run them in public CIs. Fortunately, there is a solution for that. We developed a way of like integrating custom runners and spawning machines in, for now, it's Google's cloud environment, cloud platform. So basically, if you contribute something to the repository, the system can spawn a bunch of machines somewhere in GCP, even provide them with licenses for proprietary tools, run those proprietary tools, or run open source tools, but at a scale, give you the results. And you can even filter out some proprietary information. So if you, and just provide the end result, like yes, no, passed, failed, to the end user. So this is really, really useful in those cases. The whole code of that is open source. You can find it in our GitHub, including Terraform scripts for setting up the whole infrastructure in GCP. So it's pretty easy to set it up. And if you want to know more about all that stuff, not only about Caliptra, but also about the status of open source in general, open source tooling, and open source cores, and so on, there will be a few conferences happening this year, later this year. One of them is happening here in Europe, in Munich. It's called ORConf. It's really big conference, and then really nice conference, focusing mostly on open source development in ASIC, FPGA, and all that stuff. So it will be happening in Munich in September. You can probably find Stefan sitting there, who will be hosting this conference in Munich, and talk to him, or just register at ORConf. Also, later this year, as an extension collocated with DAC in San Francisco, there will be a Chips Alliance technology update, where there will be at least 1 or 2 presentations about Caliptra. So if you want to know more and you happen to be there, you can attend this one and then get more details about that. Thank you for your attention.
Okay, thank you. Any questions?
There's one.
All right.
Excuse me? Yes, it has been renamed, yeah.
The question was, is VeeR the new name of Swerve?
Yeah, and the answer is that yes.
Okay. Any additional questions?
Hello. Yeah, so you mentioned that there was some work going on to make sure that open source tooling could support UVM tests, and I wondered if you could elaborate on maybe your view on the roadmap and how far we are from that.
Yeah, so the progress there is pretty good, I would say. My guess is that somewhere this year, like within a few months, we should be able to run basic UVM tests with validator. So I'm not saying that it will be like full coverage of the whole UVM library, or like anyhow, something that you would expect from verification framework, but base UVM tests should be runnable, I think, somewhere this year.
Nice, thank you.
All right. We have time for one more question.
Okay.
Okay, thank you.
Thanks.